Let us continue our discussion on applications of data science, this time in manufacturing. So predicting potential problems. There is for predictive manufacturing monitoring system. Often that is part of this, or sometimes it helps in manufacturing in a different way. I will come into that. Automating the manufacturing unit, maintenance scheduling, and anomaly detection. Predictive manufacturing. Now, sometimes many machineries have two, three parts which are very costly and which its maker company creates only in a single pieces and after giving order. And often the parts are made within around 3 to 4 months after the order is placed. But that means just because of one part, if that part fails, then your entire costly machinery will not run and your production will completely stop. So, what to do? Can we predict in advance that such part is going to fail? Then yes, it is possible. We can attach certain sensors and some measurement devices which measure say temperature, maybe ED currents, then which measure say uh, stress levels, strain generated in the metallic parts, and based on that they can predict minor cracks by x-rays, and then they can predict that this part is going to fail maybe after next 8 months of use. So a savvy factory owner will immediately order that part in time, maybe before 6 months or so, so that as soon as that part fails, immediately you can replace it by a new one. Your production will not stop even for one day. Then monitoring system, that sometimes there are certain devices, maybe boilers, then there are certain chemical making devices where chemical reaction has to take place only at some precise temperature and pressure. So their measurement of temperature pressure is required, but at the same time by manually doing it is either hazardous or it is too tedious. So in that kind of case, you have to put some sensors, some measurement devices which continuously go on emitting the data from boiler or from their chemical furnace where the chemical is being manufactured, and it keeps the temperature, pressure, etc. within the prescribed range. Automating manufacturing units. Now again, suppose there is a chip making company, that is a wafers, potato chips are being made, then manually controlling everything will make the production so slow that you will not be able to survive in your compared to your competitors. Ideally in one day thousands of packets of potato chips should be generated. So there are automated workflow design that potatoes are cut in one machine, then potatoes are fried in another machine, then the spices are sprinkled by another machine, then finally they are filled, the chips are filled in plastic bags, then the plastic bags are sealed. Now everything is done automatically on a conveyor belt. So as soon as first operation is done, next, and so on. And based on the past data, we know that cutting one potato is taking this much time. Then frying this many grams of chips takes this much time. Then sprinkling of spices takes this time. Packing one bag takes this time. So the machines thereafter will go on controlling themselves based on the timers that we have provided, so that there is no manual intervention needed. Now we know why companies like McDonald's or Pringles, they insist on fixed size potatoes, because if you take one small potato, one big potato, then it would be slightly difficult. So they insist that all potatoes which they want to use, they should be more or less equal in size. Okay. Then automating manufacturing that we have done, maintenance scheduling, that also I have told that if you know in advance that the eddy current or the stress and strain or the temperature or minor cracks which are not visible by ordinary eyes but visible through X-ray examinations, they are developing, then you can schedule the maintenance that exactly at this time you can stop the machinery and allow your machine parts to become cool, so that the life of that machine part increases. And second thing is there are lesser number of interruptions in your production. Anomaly detection. Now sometimes for example, you are making part for Boeing or part for Airbus or some helicopter company. Obviously there is no scope for accepting even minute defect. Now, anomaly itself means something which is not usually seen. So that means thousands and thousands of parts are created, and among them, maybe only two parts are such that they are failing. But you cannot put them in a BMW or a Rolls Royce or a Boeing or an Airbus, because if the part fails, then the consequences are very high. One, lives are lost, and second, reputation of the company is lost, and company has to pay maybe millions of dollars in compensation if it is proved that the accident or failure occurred because of the defect in their part. Okay, then this is about manufacturing. Now about this transport, self-driving cars, and we all know that Google started the project. They ran the project for around maybe more than 10 years, but ultimately abandoned that project. And nowadays, Tesla seems to be the running or leading the race. Then enhancing the driving experience. Some not completely self-driving car, but data-assisted uh, enhancements can be provided, so that if there is higher resistance felt on the steering wheel, then power steering will provide more power, so the driver will not feel the strain. Similarly, if there is snow on the road, or if there is extreme rainfall or that kind of condition, then the brakes will automatically adjust so that they are applied very quickly. Car monitoring system, which go on automatically monitoring your driving and suggest that how to improve your driving, how you can increase your fuel efficiency. They can even suggest that now it is time to get your car for put your car in the service, and so on. And safety. Okay. Here also, we nowadays have cars which beep when the all until which go on beeping until all the passengers and the driver does not use the safety belt. Some cars have reached even that advanced stage. I mean, some countries where laws are very strict that without wearing the safety belt, the engine will not start at all. So these type of things are achieved using data science. In these two, predictive manufacturing and in transport, it is IoT based data science. That is the here, not only data science will be required, but some actual parts you will have to provide, like sensors and thermometers, and that is digital thermometers and all that. Now, in banking, fraud detection. Now, for example, large companies like Visa or Mastercard, they are there, and they process hundreds of transactions every second. Among them, how to identify a fraudulent transaction. Then, credit risk modeling. That is, if there is a large bank like maybe SBI or ICICI Bank, and they have to process thousands of loan applications in 15 days time interval, then the question is, how can you minimize the credit risk? That is it possible that from the features of the applicants, how many kids they have, how many dependents they have, what is their income, what is the nature of their job, permanent or the, I mean, temporary kind of job, how much saving they have, what are their assets, what are their other liabilities? You can easily predict that among these 100 say applicants, these five are highly likely to default. These 10 have maybe 30% chance of defaulting. These 50 have moderate chance or very low chance of defaulting. While these 20, they are excellent, they have excellent credit, and they have absolutely nearly zero chance of defaulting. Okay. Customer lifetime value. Now, one very important business lesson is that it costs around 10 to 20 times more, or some surveys say that it is even more than that, to acquire a new customer compared to maintaining or preserving an existing customer. But at the same time, so companies offer some kind of loyalty adjustments or bonuses, some offers to their loyal customers. But at the same time, if you provide too much loyalty rewards, then they cost you something. So how much to offer to which customer, for which there are ways to calculate or in advance that if this customer stays with us for 2 years, then this will be his lifetime value. Lifetime word here means until he decides to switch to your competitor, then we say that customer's lifetime is over. But by that time, how much value he will generate, how much business he will give to you. So then In maybe one customer 6 months, another customer is likely to stay for 2 years, another customer is likely to stay for 10 years, then everybody should not be given same rewards. The one who has more lifetime value, that customer should be given higher rewards. Similarly, in the finance, again, same customer segmentation. If you get a customer with very high credit score, excellent financial discipline, low liabilities, and high assets, then you can easily segment in that customer into highly credit worthy. But at the same time, there is another customer who has maybe 10 credit cards, who has four dependents, maybe two kids and two parents, who is the only earning member in his family, who already has two, three more loans. Then you will segment that customer into another cluster that is called high risk customer. Then in strategic decision making, in transport also, for example, if you are a large fleet operator or truck operator and you want to design the most optimal route, and you run maybe 500 buses or 500 trucks or maybe even more 5,000 trucks, then you have to design the most optimal route which saves maximum on fuel, maximum on minimum, puts minimum wear on the parts of your truck or bus, and optimizes the wage bill of the driver. So such decisions can be taken, strategic decisions in the transport section and finance section also, strategic decision whether to acquire a company or not. If acquiring is decided, then what price should be paid for the shares of that company. Then uh, maybe whether to go for merger or whether to go for outright acquisition. Such things are decided. Algo trading, this is very important and very ubiquitous application of data in finance. And risk analytics, which I already discussed, that before giving loan or etc. Then before taking insurance also, insurance companies never lose money because they do this risk analysis, that they first calculate mortality rate, then they calculate other risk factors, and based on that they decide their premium. And the premium is decided in such a way that even when COVID or etc. epidemic came, not a single large insurer failed. So you can understand the margin which they are keeping, and that is required for safety. Because in this kind of cases, rare cases, when an earthquake occurs, or when maybe a war occurs, or an atomic tragedy occurs, at that time the mortality rate may go very high, but still insurance companies should remain and should be able to to pay the policy value to all the beneficiaries without going bankrupt. So very detailed risk analytics is done by all banks, the insurance companies, stock market providers, stock brokers, large stock brokers, investment advisors, auditors,